Hi, my name is Dale Maley. In this video, you will learn how to design and build wooden framed screens. You will find this video to be very helpful to you if you have to design, build, or repair screens that use wood frames. Maybe you also volunteer to help renovate a park and replace the old screens in the wood frames. The way I got involved in screen making was back in 2017. I had a project to enclose an open pavilion at one of our city parks called Marsh Park. That project required 28 screens, each of them 4 feet by 4 feet in size. Although I had 40 years of woodworking experience, I'd only made one screen front door in the early 1980s, and quite frankly, I forgot how I made it. I did have an existing North Park screened-in pavilion that was built in 2004 to use as a reference. Back in 2017, I went out to North Park and studied that existing building. I found out it was 13 years old. The screens were often pushed out or had to be repaired. The screen damage was often assumed to be youth vandals. When I did a thorough site investigation, though, I found the cedar wood frames were badly weathered and very little force was required to push them out. That structure is on the edge of town and experiences high winds from the west and the south. The screen material had also become very brittle. On the existing North Park design, the frames were made out of cedar. Each of the openings were approximately 4 foot wide by 5 foot tall. The cedar was 1.25 inches wide and 7/8 thick. I found out that standard cedar thickness at the Menards store is 7/8, not 3/4 like pine. Nails or screws were used to join the 4 corners of the cedar frames. The dominant failure mode, when high winds or humans pressed on the screen, it caused the rubber spline to roll out of the groove in the cedar. I made a drawing of what the original North Park design looked like. You can see the stop piece that the screen frame is shoved against, and then the screen frame itself is the 1.25 by 7/8 piece that's held in with screws to the building, and the red is the screen material, and the round spline is shown in the center. This drawing shows the failure mode of the existing North Park design. What happens is the screen frame often gets warped or distorted from the effects of the weather, and then either the wind or people push on the screen, and what happens is the round rubber spline rolls out of the groove, and there is enough clearance with the frame pieces moving around due to warpage for it to roll out, and then the screen flops in the breeze. So from an engineering perspective, if the dominant failure mode is the rubber spline rolling out of the cedar groove, why not add a small retainer piece of cedar to prevent the spline from rolling out? I also wanted to increase the cedar frame width from 1.25 to 1.5 to make it more rigid and give better joints at the corners. This drawing shows the extra piece of cedar that I added to the design to keep the spline from rolling out of the groove. Back in 2017, I searched the internet and I expected to find some design guidelines for how big the groove width and depth should be. I was really surprised there was nothing on the internet or any YouTube videos to help explain that. So it turns out the groove width and depth are a function of the screen material and the rubber spline diameter. This drawing shows the groove that is cut in the cedar. It includes the red screen material, the purple rubber spline, and then the depth and the width of the groove. So at this point I decided to do a design of experiments, which is a fancy name for just doing trial and error testing. I went to McMaster-Carr's website and I bought 1 bag each of the different diameters of the rubber spline as shown on the chart. I also bought their pizza cutter style installation tool as well, which is a critical tool that you need. I went to the Menards store in Bloomington and got a few pieces of cedar, 1 by 4 nominal size, 8 foot long. The actual measurement's 7/8 thick by 3.5 inches wide. My saw blades that I normally use are Freud's, and they're much thinner than an 1/8 inch cut, and I use those because it requires less horsepower from the saw. I searched my old saw blade inventory and found an old steel blade from my father-in-law, Lloyd Wells, and it cuts a groove exactly 1/8 of an inch thick. To run the experiments, what I did was make little screens that were only roughly a foot by a foot and use those to experiment with. And then as I went along, I reviewed the different designs with the park maintenance superintendent. This Excel table shows the results from my test work. I tried a blade thicker than an 1/8 and with an appropriate rubber piece, and did not work. And I ended up using the old Sears saw blade, worked the best. So the winning combination was the old Sears saw blade that cut an 1/8 inch wide groove. I sawed the groove 3/16 deep. I used the McMaster-Carr 1/8 inch diameter screening spline, and I added the retaining strips, and I used some special trim screws to make the 4-corner joints. Here's a picture of those special trim screws that I got at my local lumber yard, and the old Lloyd Wells steel table saw blade that I used to cut the grooves. The process I followed for making the 1.5 inch wide cedar frame pieces: I got the material from Menards, transported it home to my basement shop. I ripped those to 1.5 inch wide frame pieces. You'll get 2 of those 2 8-foot strips from each board, and I did use my Freud 10-inch blade to rip those because that old Sears saw blade was too dull to rip anymore. Once I got them ripped, I needed to put the groove in, so I changed to the old Sears steel blade. I set the depth to 3/16 and set the fence at 7/8 to be on the center of the board, or 7/16, sorry. And then I ripped the groove. You have to feed very slow because of the knots. You need to do a quality check. If you didn't go full depth on the knot, you need to saw it again, and then transport the pieces to the front yard and stain them on sawhorses. The process for making the 3/4 inch wide strips is really simple. Just set up the saw to give you 3/4 pieces and rip all of them and then stain them. Once I finished making the pieces in my basement shop, I used string to tie them into bundles so they wouldn't come apart, walking them up the basement stairs and out to the front yard. Doing all that ripping work on the saw does generate a lot of waste. Cedar strips, thin strips, as shown here. Screen material comes in standard roll widths. 48 inches and 60 inches are typical. Check with your local lumber yard. They should have a catalog where you can pick out the type and size of screen you need. If you're designing a new building, you need to take into account when you're doing your framing that your screen width of 48 or 60 inches really controls what size opening you should have in your framing plan. Here's a typical framing plan that I used at Marsh Park, for example. I did investigate alternatives to using wood cedar frames, like using aluminum, but boy, that was really cost prohibitive. And then other people told me that they had worked on old buildings with aluminum frames and they still had the issue of the spline popping out of the groove. I used a water-based stain for all the pieces required to make the screens. It's really a labor-intensive process because you have to stain or paint all 4 sides of each wood board. In many ways, trying to make cedar frames for screens is trying to make a silk purse out of a sow's ear. Why is that? It's because the cedar boards are full of knots. They're also warped. So as you go through the processes, try to make good decisions like selecting the best side to saw the groove into, select the straightest pieces when you're cutting out your frame lengths, and try to avoid using knots at the end of the frame boards because the screws won't go into knots. Be sure and set yourself up a nice flat work table. You could use the top of a picnic table, or you could take a piece of plywood and set it up on 2 sawhorses like shown here. This picture shows all the tools that I use to make my screen frames, including the wooden handled pizza cutter, which is demanded for this job. Here's a list of process steps that I use to make the screen frames. I won't read through all of them verbally. The most important and most difficult is getting the rubber spline started with a tool and then pushing it into the grooves. Here's a photo of the finished Marsh Park project where I had to make 28 screens. Here's a picture of the North Park project that I did in 2019. It required making 38 cedar frame screens. In the winter months, the city crew comes out and installs plywood sheets between the cedar frame screens and the outer stop on the building. Then in the spring, when the weather gets warm, they remove the plywood so you have the screened in frames during the summer months. Here's a photo of back in 2017 when I was measuring and cutting and making the plywood panels that are used in the winter months at Marsh Park. Thanks for watching this video. I hope you find it useful if you are involved in making or repairing wooden frame screens. Thank you.